Inter and intramolecular forces by Sabrina Close, Sarah Rostigari, and Sofia Iwatsova in Period 8. Let's start with the basics. Intermolecular forces are forces that are found outside of the molecule. This type of force is the attraction between one molecule and another and also determines what phase it is at room temperature. There are three types of intermolecular forces: London dispersion forces, dipole-dipole forces, and hydrogen bonds. Think back to before winter break. Remember how electrons are in constant motion? As seen in the picture, the London dispersion force is created by unequal distributions of electrons that create slightly negative and slightly positive charges on each side of the atom, which then attracts them to other adjacent atoms that have that opposite slight charge. Fritz London was the one that suggested that the motion of electrons in an atom or nonpolar molecule could create a short-term dipole bond in 1930. Dipole literally means two poles, positive and negative. This leads into our next force, dipole-dipole. Unlike London dispersion forces, this type of force is where atoms have permanent dipoles through covalent bonding and therefore have that same slightly positive and slightly negative end, which are attracted to other atoms with that opposite slight charge. Hydrogen bonds is the next type of force, but it has a unique type of dipole bond. Hydrogen bonds are created when oxygen, nitrogen, or fluorine bond to hydrogen. Since oxygen, nitrogen, and fluorine have such high electronegativities compared to hydrogen, the oxygen, nitrogen, or fluorine atoms in the molecule have slightly positive charges and the hydrogen atom has slightly negative charges. Van der Waals forces, named after Johannes Dietrich van der Waals in 1881, are all the intermolecular forces that are between electrically neutral molecules that attract the molecules to one another. Intramolecular forces. There are three types of intramolecular forces: ionic bonds, covalent bonds, and metallic bonds. Ionic bonds are formed when an atom almost has a full shell of valence electrons and another atom almost has an empty shell of valence electrons. This is shown by sodium and chloride. Sodium gives up an electron and gives it to chloride, so now sodium has a positive charge and chloride has a negative charge, but their shells are full. Covalent bonds are formed when two atoms share electrons to create a full shell. This is shown with two hydrogens. Each hydrogen only has one electron, so to fill its first shell of valence electrons, there only needs to be two. So if they share electrons, then each atom gets a full shell. Metallic bonds are positively charged ions that float in a sea of negative electrons. The positive and negative charges keep it attracted to itself. This allows electricity to be conducted easily since the atoms only had a weak bond. This also makes it easy to bend and shape metals. Electronegativity is the tendency of an atom to draw electrons to itself. This explains why an atom wants to have a full shell, because the elements with the highest electronegativity are the ones with a full shell. As you move up a group and across a period, the electronegativity increases. Electrostatistics explains the attraction from a positive charge to a negative charge. This helps explain the trends in the intermolecular forces as well as the metallic bonds. And that's it. Thanks for watching.